Okay, so we will wrap up by merging these two concepts where we will have right triangles and we might have a side missing instead of just finding a ratio. So first thing we're going to do is identify the angle that we're given, 41, and what sides we have in relation to that. So I have the side right next to 41, which is our adjacent side. And I also have the side across from 41. So that's going to be our opposite side. The hypotenuse is always across from 90. We don't have that in this triangle. So our options, I always like to write out my SOHCAHTOA. Our sine, cosine, and tangent. So we want to find the function that uses opposite and adjacent. So that would be TOA, opposite and adjacent. So that we know tangent is equal to our opposite over adjacent side, and we can set that up. So for this problem, we have tangent of our angle equals our opposite side over the adjacent side. And again, I'm going to solve for x. So here, x is on the bottom. I can multiply that across. So I get x tangent 41 equals 12. And finally, to get x alone, I'm going to divide that whole tangent of 41 over. So last, x would be, in my calculator, 12 divided by tan 41. I'm going to put that in for us. 12 divided by tan 41. And I get 13.80. So that's our first one. On the next slide, you'll have this triangle I have on the right. So I'm just going to get us set up for that. One more practice. So here we're given 39 degrees. This time I have the hypotenuse and the side right next door. So that's our adjacent side. So looking at our SOHCAHTOA, hypotenuse and adjacent are in the middle here. Adjacent hypotenuse, and that is our cosine. So I'm going to use cosine of 39 degrees equals adjacent over hypotenuse. So you guys can finish solving that and try out the rest on the next slide.